Can you see this?
Yes.
Okay. Our topic is the introduction to civil engineering. In this class, I need to take two sessions. In the first session is the introduction to civil engineering. Please mute the outline of this session. Here I am going to take in this section what is engineering, what is civil engineering, and branches of civil engineering. The engineering is the branch that is the continuation of the physics, chemistry, and mathematics that we studied in +2. Okay. In this engineering, the Robert E. Dory, as per his opinion, is a electrical engineer and AIE medal winner. That is American Institute of Electrical Engineering. He worked as in 1909. As per his opinion, engineering is the art based primarily upon training in mathematics, physical sciences, utilizing economically the forces and material of nature for the benefit of man. The base thing of this engineering is the forces acting on any body and the material. Thus, this science is based on the engineering. Engineering means the application of science for the fulfillment of needs and betterment of people by use of material, other resources, and controlling power by means of engines and machines. Engineering is concerned mainly the designing, fabricating, erecting, manufacturing, installing, operating, controlling, and maintaining the engines, machines, instruments, and equipments, as well as the constructing structures. Generally, the mechanical engineering and civil engineering are the base streams in engineering, and then electrical engineering, electronics, computer science, etc. Are all the sub branches are developed in later. What is civil engineering? Civil engineering is the field of engineering concerned with planning, design, and construction for environmental control, development of natural resources, buildings, transportation facilities, and other structures required for health, welfare, safety, employment, and pleasure of mankind, as per the Frederick S. Merritt. He is the experienced civil engineering in for many years in building design, bridge design, construction management, and also he is the author of more than 30 books in civil engineering field. Civil engineering can be described as engineering concerned with designing, constructing, and maintaining works of public utility. Civil engineering is the branch of engineering profession which deals with planning, designing, and construction of the structures. Then the field of civil engineering. Civil engineering involves the facilities, installations that people generally use. So this means that the profession involves the finding out what is required and making it happen. So it includes the analysis, planning, design, construction, and maintenance. That is the whole life cycle of the different facilities that people use. So this could be The government facilities, these could be the for the businesses, industries like factories, shop floors, and so on. The facilities that are used by the general public, like bridges, roads, and other such installations. So some examples of facilities that are created by managed by civil engineers are high-rise building, office towers, residential buildings, factories, schools, airports, and other transportation facilities like tunnel subways and other systems which are needed for providing drinking water and also for treatment of sewages, dams, canals, water purification systems, and others that we need for protecting the environment. Okay, we want to make sure that the sewage that is created from all these townships and offices are treated properly before they go back to the environment. So this would be a broad definition of what is the field of civil engineering. The purpose of civil engineers in society is that they coordinate the needs of society. So broadly, when we talk about the civil engineering, it is the response to what society wants or society needs. So civil engineers coordinate the need of society, that see what is required and make it happen within the limits, when within the feasibility, that is the technical and economic. Okay, what does technical mean? It is doable, it is possible with the technology that we have here. It is possible with the resources that we have here, manpower or raw materials. The scope of civil engineering is mostly determined by economics because somebody has to pay for these facilities, and it is the public which directly or indirectly pays for these facilities. So there are limitations for constraints due to the economics. Civil engineers are concerned about the impact because that we do as a civil engineer affect peoples directly. So the impact of the project on the public is very important. And also we have to be in equilibrium in with the environment. So we don't want to create something that spoils the environment and takes it to a point that it is not renewable or cannot be returned or to its original state. So the impact has to be positive. The people who are using facilities, and at the same time it should not be negative or extremely negative on the environment. So this equilibrium for this balance is always kept in mind by the civil engineer. Civil engineering unifies many fields. Later, I will talk about some different disciplines of the and or specialization in civil engineering. See that each of these specialization talks about. At that time, I will give a brief introduction to each of these specialization. So, we use the sciences and we use the maths, physics, chemistry, sociology, ecology to create the manage these different facilities of civil engineers, how to take care of. You can see a graph. It's a relation between natural environment, people, built up environment. Okay. In this natural environment, for green cover, climate, water, air are included in the natural environment. In the built environment, planning, architecture, design, construction, maintenance. At the same time, the people, they needs the habitat, water, comfort, safety, hygiene, transportation. All these things should be in mind for a civil engineer. So, what I said can be put in the form of a graphical form. Hmm? We have people and we respond to the need of the people. We create facilities that would be called built environment. That is shown in this figure in the lavender color. But all this has to happen in coordination with or along with or in conjunction with the environment and without spoiling the environment. What are the aspect of the factors that could be important when we talk about the people, civil engineering concerns, where they live, that in that is in the habitat. We want a comfortable place where people can live. We want to provide facilities like water, drinking water is a facility, okay, or a requirement of anyone. In general, they should be comfortable. Generally, the people should be comfortable with the water, facilities, the safety, etc. So the place given for the people to live and work should have should must have proper ventilation, should have proper lighting, and they should be able to be comfortable when they are living there or working there. Excuse me. And also, mm, for the people, that is shown in the red color in our graph. Uh, for the people, the second thing is the third thing is the safety. Safety is very important. Safety against any type of threats, people, the environment, and natural hazards. Suppose there is an earthquake or a cyclone is happened, we want to make sure that our facilities keep people safe. Please mute. Similarly, if there is a flood in a city, we do not want the building to be unsafe. People inside the building in our facilities that civil engineers create, they should be safe. The next point is the hygiene. Hygiene is very important. So this means that the wastewater is treated and mitigated well. People have to move within the cities from one city to another or city to rural area or back and forth. So transportation is very important. Nowadays, we spend a lot of time moving. People, because people are much giving much time for traveling, moving people and good back and forth. So it is very important that transportation facilities are good. Okay, but people spend a little time to possible in moving from one place to another. Finally, in our graph, and it is very importantly, the construction sector of civil engineering sector provides a lots of jobs. Civil engineer facilities are not only important for doing the job, but also civil engineering creates a lot of jobs for skilled or unskilled workers. Okay, construction provides a lot of jobs, especially for unskilled people. So these are the important aspects as far as people are concerned. Then we have to discuss about the natural environment. Then we have the natural environment. So all this has to be happen within the world that we live in. And this means that the environment has animals, plants, insects, birds on. Um, we have flora and fauna that we do not want to destroy, but we have to live within the same ecosystem. The green cover is important. How much of the earth or how much of the land that we use green? We want to keep it green as possible. We means the civil engineer. We do not want to use up everything and therefore we will hurt the environment. climate can also change anytime. We, we talk a lot about climatic change. We talk about ozone layer. We where industries, even construction activities emit substances, emit gases, and so on, which can alter the climate and affect the whole earth, including us. Water and air pollution is very important. We want to keep the air and water as pure as possible. So here we have to do things people th- so we have to do things properly, starting off the planning. We have to plan much ahead of time and properly before a project. What are the requirements before a project? What are the requirements that we have? What are the installations that we want? The architecture becomes more important, and later on, you have a architecture and how it developed, how architecture leads the structures, and we construct. We have to design. Design means coming up with an optimum way of executing what we have planned. So design is where we have all the sciences in our hand. We have all the technologies. We decide which to use, how to use the optimum way. Optimum is the sense of raw material usages. And in this slide, I finally conclude in this slide. And finally, most of the structures that we build have to last for every long time. Say a bridge, for example, a bridge in a city has to last at least for 400, so for 100 years. I need to describe about the main need of maintenance. So say a bridge in a city has at least for 100 years. That means that we have to maintain it and take care of these facilities and repair them if necessary. So this is the whole system that we have to consider. We have people, we have natural environment, and we are building this environment to satisfy the requirements of people without hurting the natural environment. So the major impact of the civil engineering is where all this comes in, avoid conflicts to make sure that everything is done without hurting the environment too much, without it being too expensive, but responding to what people need. So this diagram tells you where we are working as a civil engineer, and where the major impact. We can please go to the next slide. These are the some inspirational project. I show you just only two examples. First one is the channel tunnel. It is a very good example for our civil engineering. It is a very sorry. This channel tunnel. This channel tunnel. It is a tunnel linking England to France. You can see this slide. This is the United Kingdom and this is the France. This channel tunnel is the underground way of through the underground of pathway below the sea. A 50-kilometer tunnel going under the sea linking the two land masses. This is the United Kingdom and this France. The lowest point is about 75 meters. So it goes under the sea to a maximum depth of 75 meters. The cost of this about 21 billion US dollars. It saved or it helped 28, but it helped 28 million passengers just in its 5 years, first 5 years. 12 million tons of cargo went through this tunnel in the first 5 years. So instead of using ferry or instead of using the ship, things between England and France, now people could use this tunnel, just drive through and have a train passing through. Again, you can imagine the difficulties or the challenges of having a tunnel that is going under the sea. Obviously, it should go correctly. The direction you want, it should not leak. It should not collapse. You have all this mass of water on the top of it. And the soil also support. So again, I'm saying it was very challenging and an inspirational structure. This is the sectional view of this channel tunnel. This is the seawater. This is the underground path. This is the top view. I think it is taken the Google Maps too. This is the inside view of this channel project. Okay. Next, I'm going to the another example of our inspirational project. This is the Palm Island in Dubai. You can see in this figure the final stage of the Palm Island, and this is the I take Google Map view. This is the photo at the construction stage of the Palm Island. Okay. It is very close to Dubai. Another engineering marvel was construction of land. Where there are no land. So Dubai wanted more of coastline, wanted more of island. So, okay, continue. The Dubai want more coastline, want more land. So they just created islands. And these islands are so big. You can see through this way islands are making. So in the left side of right side, I think it is a clear picture. So these are the large structures. They add 522 kilometers of coastline to that of Dubai. The first two islands used 100 millions of cubic meters of rock and sand. Okay. So in the sea, islands are constructed and these islands have become building houses, hotels and so on. So civil engineering is so powerful that you can create for living, and in this case the sea, and there was no land. Another example is Burj Khalifa and many of others. We have not enough time to explain them. So we are going to the next part of our section. Okay. In the introduction of civil engineering, I explained just the requirements and the need of civil engineering. Then in the civil engineering, it is nowadays several branches are offered. The main specialization or main branches civil engineering specialization are these things: environmental engineering, geotechnical engineering, so the environment, looking the environment, how we interact with the environment. Environmental engineering explains how we interact with the environment. How should we take care of the environment? These all things are happening in the environmental engineering. The next one is the geotechnical engineering. It covers the soil, the ground. Next one is the hydraulic and water resources. This deals with the flow of water. How we can control and save the utilize the water more better. Then the next one is the construction material and technology. They would look at that what is used in construction. What are the technologies available and how do we efficiently how construction is going on? Next one is the structural engineering. This is a core paper of the civil engineering. The structural engineering deals with the design and analysis of structure that we want to construct. It is very important in this stream. Next one, the transportation engineering is as the name implies, deals with the planning, design, and construction of all transportation facilities, mainly roads, railways, ports, airports, and so on. Okay. Next is the construction management. Seventh one. It is very broad discipline which take care of managing using resources efficiently, whatever. The civil engineering project we take up. Finally, some others and another stream is the urban planning. Sometimes come first before everything else starts. So look at what city excuse me, look at what city should come up, how they should develop, and even projecting how they will develop in future. That's comes under the urban planning. We can see in detail the environmental engineering. In this slide, the right side, this is a large treatment basin in USA, the wastewater treatment plant. Then next left side, this is also a wastewater treatment plant. This is the pollution and mitigation system is shown in the second figure. We can start with the specialization streams from the environmental engineering. Environmental engineering deals with providing water that is drinkable to people, taking care of wastewater, treating it so that when it goes back to an environment, it does not harm to the environment. So at the top, you see a picture of wastewater treatment plant. This is a picture uh, where there is water that is coming from the sewage or household and industry treated such that it can be put back to the environment. Another aspect of the environmental engineering is the pollution monitoring and mitigations. As urban environment comes up, the cities comes up, we pollute the air, we pollute water, or we pollute the groundwater. So monitoring of this and mitigation is very important because just knowing that this is happening is not enough. We have to see how to stop it and how to make sure that the pollution does not keep on increasing. Otherwise, our cities are going to get dirtier. The air that we breathe isn't going to become more difficult to breathe, and our groundwater will become contaminated, and it will spread to the environment all around the cities as well. In this environment, mental engineering, this all is aiming to protect the improve the natural environment. Uh, environment. It draws upon basic sciences like chemistry, biology, fluid mechanics, because these are the sciences that are required for designing, operating the system that have to be built for providing the drinking water and for treating waste, municipal waste, municipal as well as the industrial waste. Depending on where the waste come from, treatment may be different. We have to see that the contaminants are how they can be treated or handled before the treated waste is sent back to the environment. This is also bring up very importance in civil engineering, knowing the chemistry. Okay. The next stream is geotechnical engineering. This is the geotechnical engineer, as the name implies, is whatever that we has to do with the earth, the soil and ground. So suppose we have to make a tunnel. For example, in this image, given a large tunnel network. Can you see this figure? This is a tunnel construction stage. The tunnel dredging is seen in this figure. The image given here, a large tunnel network being built. The tunnel have to go through a mountain, go through a rock, or go through soft soil. Anyway, we have to understand the soil. We have to understand the rock. We have to see how to make this tunnel safe or not. We are drilling. Okay, boring and when we are drilling or boring, and also during its life, it has to be safe enough, and it should withstand the pressure of the earth around it and the movements and so on. And whenever we have a large building or a high-rise building, you need a strong foundation. I want to explain about the aspects of the geotechnical engineering. First, I just mentioned about a tunnel engineering. Next, I want to tell about some building related matters. Whenever we have a large building, a high-rise building, you need a strong foundation, because everything that we see above the ground is transferring the load to the ground. So we have to make sure that that is going to be stable, because our building must be safe. So we have to understand how to make the foundation of the structure so that they will last long time and keep the building safe. Also, we have to understand the earth itself can move or not. The ground can move. When there is an earthquake or when there is a settlement, uh, when there is a settlement that happens. So we want to make sure that it stays stable. Okay. So there are techniques where you can strengthen the ground. So there are ground strengthening techniques. If the ground is not strong enough for what you are going to put the top of it, or we can strengthen the ground in another ways. Another technologies are there. So may not have a choice to say that I cannot build here. I can move elsewhere. So we have to see how to make the ground strong enough for whatever we are constructing on top or within it. Excuse me. This is in this picture. This is a ground strengthening method is seen shown in this, and this is a foundation of a high-rise building. A geotechnical engineer or a civil engineer, this comes under geotechnical comes under the civil engineering. Understand earth material, whatever is in the ground, and see how to design say foundation for structures that we are going to place on them or within them. So so we want to analyze the behavior of soil and rock so that we can design the structure safely. The structure could be a high-rise building, could be maybe a pavement or underground facilities, tunnel or anything. Foundation design, as already discussed, for the high-rise building. It is very much required for any type of structure, because the ground has to withstand the loads, should not deform, too much, and it should be safe enough for the structure to sit on it. Slope stability is very important because we have some areas where we have to cut through mountains, hilly areas. When we make a cut, we leave a slope that could become unstable and collapse. Okay. And we goes to the next slide. That is the next stream of the civil engineer. That is the hydraulics and water resources engineering. This is a dam. And this is the first figure. Which deals with the ground is how water flows on the ground. This is the another aspect. Excuse me.
Yeah, good evening. This is Charles. Hello, ma'am.
Now I want to explain hydraulics. In this hydraulics, the water resources engineering. So there are large structures like dams that have been built over the course of history. We still build a large project which involves dams where water is stored for the irrigation purposes, drinking water purposes, and also to generate electricity. It is one of the cleanest ways to generate electricity. We have several large hydroelectric projects which provide this pressure due to the buildup of water that can be used to generate electricity. These, these are all massive projects because they involve making a huge reservoir that can collect the water. And the impact on the environment and people is tremendous. So they have to be done properly and safely. This water is often transferred to the places that we require them. This is an example of the canal. Okay. Canal through the desert land. Can we, through this, we can convert the water to the liable places where you can, where you can have irrigation by having proper canal. So this will require us to understand where to store the water and how to move the water, and water has to flow by gravity. So we have to understand how to make it flow in the direction that we want to and it and it should reach in place that we want to do. The another And sometimes the disaster happens, say floods. That is an image. It is an image of flood. We find that sometimes there is too much rain. There is too much flow of rainwater, and it could flood in a city that is inhabited by the lot of people. So here again, our hydraulic engineers, we will have to estimate when this could happen using the statistics, using the knowledge of the historical data. They have to guess what would be the maximum rain, when would be the maximum rainfall that is the reasonable used for this design. And if this rain falls, how is it going to be handled such that it does not become unsafe for the city, for the people, and for the businesses in the city. So there is a lot involved in the storing and conveying water. In the another hand also, we are worried to protecting too much water from coming into the city and destroying the city and its people. We are not explaining deeply. The next stream is the construction materials and technology. In this figure, it is a large construction site is happening. These green lines. These are the concrete concreting pump. This is a tower crane, and also this is a tower crane. Next one, this is a new technology, the 3D printing of the concrete. Okay, we can come to the area of the construction. Construction involves the resources and material and processes. So the people who are involved, the construction materials have to decide the material to use and how much to use and how it. This is mainly the a kind of management. Okay, the construction working and material management and time management. So we have an image in the huge construction site. This we can see this is a construction site. These green lines that you see here is a pump, concrete pump delivering. Here is a pump delivering concrete. Can you see this? You can see a bunch of them. And then there are a then these see in this figure are the concrete trucks here. And this is now going to go into this huge construction site where probably the foundation of of a very tall building in the set of building, and it is come up. So construction material expert has to know which concrete to be used for this construction, how much should be delivered, how it should be delivered, the and that the construction technologist has to see what are the equipments required so that this material will be delivered correctly and on time. We see here some cranes. So material has to lift it. This is the crane for the material transportations. Uh, uh, Using this crane, the material has to lift up during the construction. How many cranes do we require, and what is the type of crane required has to be decided by by somebody who is going to tell us what type of technology is best suitable. Here, you have a tower, and as the tower is building it, the crane is going up by itself. You see, this crane is attached to by a tower. This crane is attached to by a tower. So as the tower is growing, the crane sorts of moving itself up. So the crane is always above the tower so that it can lift things and put on the top of the tower. Concrete might seem a very ordinary material. Everybody thinks that this this is the 3D printing of the structure. Everybody thinks that they know that everything about the concrete, but there are people who do a lot of research for the concrete. And now this is a new thing in the concreting that is which is about this is 3D printing. This structure. This is a 3D printing. 3D print everything while for concreting. This is an image of wall concreting by using the 3D print. So we do not need a mold for the or a form work. You can just view the concrete and it stand up. Okay, as the required shape of our structure. That is coded before this. This is being done in polymers. In this type of concrete 3D printing. It is being done with the metals and some other kind of materials. It is a new technology of construction based on the technology and reducing the manpower and construction time in effective way. I think All of you are heard about this technology of 3D printing. The next stream of our branch is structural engineering. When we have to the structure, we have to look at the people who take care of the foundation and people who have taken care of the material and processes. Now we have to design a structure. The structure like this high-rise building or this bridge across the Yamuna River in India. This bridge. This is a cable stayed bridge where we have a deck over with the traffic is flowing, but the deck has to be kept across the river. And we have cables which are holding it up. These cables are tied to this huge tower, which is above the bridge. We can have a steel bridge as well. This is a very elegant. Next example is the Howrah Bridge. This is the another bridge, also is in India, Kolkata, which shows the entire steel bridge, and it is a skeleton of structure, steel that is holding it up. So these are the things which are very impressive. They could be tens of, if not hundreds of meters tall or long, and they have to be designed a safe way and to last for a long time. So this is the structural, this is what the structural engineers does. The structural engineer analyzes the forces, stresses, and deformations, and finally they designs the structure so that it will resist the loads and many other actions. Okay. The designed structure must resist the load and the other action. The loads that are coming because of the people using, the weight of the material, movements due to the wind or seismic action, and still last for a long time. And when they last, we want to take sure it is functional. Next stream is the transportation engineering. Transportation engineers design and analyze the highways, railways, airports, urban and suburban road networks, parking, and traffic control signals. It is very important. The different modes of transports are there. In our every nation, we have national highway network where several thousands of kilometers still have to connect the different corners of nation, similar to roads providing modes of transport, waterways, and also provide a ways of transport. Canals, waterways has the mode of transportation because we can transport goods very easily. By waterways, the goods can be transported very cheaply without competing with the transportation of people. This could be a mode that is dedicated to the transportation of goods. And airport construction at remote area, hilly areas, difficult to do the construction, but all this important for providing a network for moving people, moving goods, and keeping business and life going to be one thing. Next stream is the construction management. In the construction managers are mainly doing the review of contract, order of materials, hire and schedule the subcontractors forever. The job of construction managers to provide quality control and ensure the project it is completed on time and within the budget. Time schedule budget is very important in this construction engineering. In this area, the contract is very important. The contract is the agreement between the contractor and the owner. And there is the agreement saying much saying that so much money given, they will do the work in a certain way, comply with the rules and comply with the specification. And how to, so there will be some problems. There will be always something that went wrong. How do you deal it? So these things that the construction managers does. They plan, coordinate, and control all civil engineering projects. A construction manager can look the equipment requirements, also the designing of formwork frameworks, and concreting, and that it he makes a shape. Uh, you want the structure. Very important area is this is a very important stream in the civil engineering for a good construction. The proper management make sure it is a very safe at site, and materials, labor requirements, money and time, delivering good qualities can be maintained. Okay. In this session, I completed the main areas or introduction and main strains. And I also want to, in the second section, a small area that is the components of buildings in because civil engineering is really connected with the building construction. In this session, I want to explain some points, components of building, what is a foundation and what are the types of foundation. Mainly a building consists of mainly three parts. First one is foundation, second one plain superstructure. We can see this figure. In this figure, this area is plinth. That is, the area below the ground level is called the foundation, and this is the floor level. Can you see in this figure? This is the floor level of a building, and this is the ground level of the building. And this area, this height, mostly it is 45 or 60 centimeters as per the requirement of the building. This is the plinth area, and the part of the building below the ground level, it is called the substructure. The part of the building above the ground level is called the superstructure. Superstructure, plinth is also included in the superstructure, and mainly three parts are included. And we can see the figure. Also, we can explain some parts of the building. This is the subsoil. This is the foundation of the structure. Then above the plinth level, this is the floor level. Can you see? This is the floor level. The flooring of the building is here. And above this, we can see a window. The top of the window, there is a concrete belt throughout the building. This belt is known as lintel. And sunshade is connected with this lintel. Sunshade is provided for the protection of the windows and protecting about water, rainwater, and sunlight, or etc. Then the bottom level of the window, it is called window sill. The top level of the window is called lintel, and the bottom level of the window is called sill. This top level of window, and normally top level of window and doors are same. The lintel is normally 2.1 meter from the floor level. And then this is the roofing of the structure. This is a two-story building. So this is the first floor and this is the ground floor. This hatched area is also the roof of the ground floor. This is also a roof slab. This is a storage tank. This is the stair, and a door is shown here. And this is the wall area. Anyway, wall area, roofing, window, all things comes under the superstructure of the building. Then we can explain in this session for the foundation. Foundations is mainly two kinds of foundation. First one is the shallow foundation. Second one is the deep foundation. Shallow foundation is the foundation with the lesser depth. Its definition is depth of foundation is lesser than or equal to the width of foundation. I didn't write here. The types of the shallow foundations are spread foundation and mat foundation. The deep foundation means the depth of foundation is more than or equal to the width of the foundation, because the pile, diaphragm wall foundation, pile walls, caissons are the examples of the deep foundation. The advantages of the shallow foundations are cost must be affordable. Its construction procedure is simple. Mostly it is concrete, lesser labor requirements. This is the example of the shallow foundation. This is a spread footing. It is also known as footing. It is the enlargement of the bottom of a column. This is the column. Okay, this vertical load bearing member is column. This vertical load bearing member is called a wall. If the column type structure is this shown, this cuboidal area or rectangular area is known as the footing. It is the enlargement of the bottom of column. This foundation transferring the load from the column to the soil below it. And this is load bearing. This is the spread footing. The load from the wall is transferred to the soil by this foundation. Spread footing may be built in different shapes, sizes, square or spread footing, rectangular spread footing, circular spread footing, continuous spread footing, combined footing, ring footing. This is a square type foundation. This is the column and this is the foundation. Okay. Normally this is the reinforced concrete boxes. Next one is the rectangular spread footing. This is only based on the shape of this foundation. Next one is the circular. We can see it have a cylindrical shape. And next one is a combined footing. Here two columns are here. This supported by a combined rectangular area. Next one is the ring footing. This is a concrete ring foundation. This load is transferred through this ring. Next one is the mat foundation. This foundation, the entire number of columns are here. These all columns are rest on a single mat. This is called a mat foundation. Next one is the deep foundation. The examples are piles, piers, caissons, compensated foundations. These are the piles. Slender or structural member consisting of steel or concrete timber. This short in this figure. These are the pile foundations. This transfer the structural load from a significant depth below the structure, below the building. Pile foundation used when the soil near the surface does not have sufficient bearing capacity. Bearing capacity means the ability to withstand the load by the soil to support the structural load. The estimated settlement of the soil exceeds the tolerable limit. When pile foundations are the soil below the foundation is very weak. Differential settlement due to the soil variability. These are the two types of the pile. This is the end-bearing pile and this is the friction pile. This end-bearing pile, this is the rocky area. Our building area is here. Our ground level is here. This area is weak soil, and under a certain depth, we can find a strong area. This pile is ended to this strong area. Pile will transfer the load to the soil layer under a ground such as rock, gravel, or very dense sand. Okay, this end is bearing on a strong area, so it is known as a end bearing pile. Next one is the friction pile. Here the rocky area is not found under a certain limit of depth. This pile is rest here on the smooth or weak soil by its skin friction. This skin friction. Pile transfers load from the structure to the penetrable soil by means of skin friction or cohesion between the soil, the embedded surface of the pile. Okay, thank you. Okay, thank you.
Thank you.
Okay, thank you.